let's give a big hand to Annalise for being on the IT here. I recently had to be in her shoes at the IPS Connect conference, and it was terrifying. But anywho, all right, we'll bring up our next presenter. We have Gus Lewis, and his project was micronuclear reactor modeling in Alaska. And yeah, his mentor was David Denkenberger.
Well, last few days, I've been telling Osius how much I hoped he fell apart mid-presentation just to make myself look better. But he just blew that out of the park, so I'd like to thank him for that. Yeah, so Jeff kind of nailed down my intro. Okay, so the bottom line for us was we wanted to look at 4 different nuclear reactors, and we wanted to see whether or not they were economically justifiable in lowering energy costs in 4 different Alaska sites. Those are the 4 reactors we're looking at. If you want more info on them, you can email either myself, Dr. Denkenberger, or Dr. Ray. As mentioned, the 4 sites we were looking at are the UAF campus, Red Dog Mine, Fort Wainwright, and Kotzebue, although we may transition into Barrow from Kotzebue, depending on how much data we have present. We want to look at 2 different reactors per site. We want to look at what the economic benefits and or possible disbenefits are of each reactor. We also want to look at how the emissions compare to whatever the current technology and use is at that site. And then at the end, we want to see if it is a justifiable transition. So you may be saying how this relates to Acep. So I've kind of dummy proofed it here. I've put, this is right off the Acep webpage. Acep is focused on lowering the cost of energy throughout Alaska, and that is the sole purpose of this summer project. We want to look at is nuclear a possible alternative at the advertised cost for what these reactors are being, claimed to being sold for. And if they're not, we want to look at what cost they need to be, available for before they do become a justifiable means. So here's kind of a step-by-step process. So the top bullet's more of Dr. Ray's area. He would get in contact with each site and get the load data and give it to me, at which case I'd begin modeling in Zendy, which was the software we used. The first thing you'd want to do, at least what I want to do, you want to develop or model whatever the current technology and use is at that site. So for UAF at the campus here, the first thing I'd want to do is model the current power plant. One problem with Zendy, though, is it does not take into account future needs or developments. So the power plant here is, I believe, 17 megawatts, while the electrical load is only around 5.8. Zendy would not construct the additional 11 megawatts. So it's only going to produce enough to meet the load. So the way we kind of got around it for this project is we would take whatever the current technology is and then find the price per kilowatt and then scale it to so where Zendy would start to build that technology. Once we have that base case or the current technology is developed, we would then install or present Zendy with a nuclear alternative. And the way Zendy works is if you have, usually we would have a coal base case and then a nuclear alternative. Zendy would then choose based on those 2 options, which is the most economical method to meet the load. Sometimes it might say it's best to invest everything into nuclear. Sometimes they'll say to exclusively meet the load through coal, or sometimes it would use a combination of the 2. So for Oklo, for example, the Oklo Aurora model is being advertised for 10 million. At that cost, Zendy calculated the best thing to do would be to purchase 5 1.5 megawatt reactors to meet the load at UAF. So I would then begin to increase the unit cost from 10 million up to a certain price to see at what cost would it no longer be the economical or the most economical method. Similarly, the second reactor we did at UAF was the Avinci model, which has a advertised cost of around 44 million, so a little bit more. At that price, Zendy found that it's best to stick with coal at UAF. So I would begin lowering the cost of that model reactor to see at what price it would have to be rolled out for before it was found to be the most economical method. So there's just a lot of price fluctuations. We wanted to see, what the best cost is. And then we would take in Zendy, it gives us the annual costs, along with the investment cost of each unit price or each optimization. So I would then transfer that data into Excel and calculate over a 20-year study period, which is what we were looking at. So here's kind of one of the graphics we have for the Oklo model at UAF. You can see along the x-axis, we have our decreasing Oklo unit cost. Along the, what is my right, the total capacity is how many megawatts Zendy is constructing of each technology. And then we have the savings over on the far left. So you can see at the $29 million unit cost is essentially what is our coal base case. At that unit cost, Zendy is only going to construct coal to meet the load at UAF. And then as we decrease our unit cost for an Oklo reactor, we begin to see more and more nuclear technologies being constructed before eventually at the $16 million price point, Zendy calculates we should construct 5 1.5 megawatt reactors to meet the load. And then I believe the savings peak at around 30, I want to say 31% in that ballpark, while the CO2, that was cost savings peak at around 31%, and then cost or CO2 savings plateau at around 27%, if I remember correctly. Challenges, receiving data wasn't exactly a challenge, but there's, lag time waiting for some of the nuclear reactor folks to get back to you with data. Zendy, whoops. So in Zendy, nuclear reactors are not a technology you can model. So the way we would get around this is we would construct a natural gas generator and then change the inputs to where it represented a nuclear reactor or a micro reactor. Similarly, as a fuel source, coal is not a fuel source in Zendy. So we would have to model it using natural gas and again, change the input to where it would represent coal. And then Zendy, the other thing it requires is a continuous fuel cost. So with a lot of these reactors, the lifetime outlasts the refueling period. So most of the reactors had a refueling period around, 8 to 15 years. It would need to be refueled. Whereas Zendy would need a continuous fuel cost. So we had to change that single payment into a continuous cost or an effective cost to model that. The changes, probably my biggest frustration with Zendy, all the calculations are done online. So it does not show you where the numbers are coming from or its final answers. So I'm not too keen on putting values into a report I don't know where they came from. So I would take the data and put it into Excel, and most of the values came out pretty similar, but I just want to make sure. So I wish I'd transferred over to Excel sooner rather than later. Future improvements for the past summer, we really only dealt with cost. We didn't change the electrical efficiency, or we didn't play with the electrical efficiency, nor did we change the heat to power ratio of the nuclear reactors. So if someone were to pick this up, I'd recommend starting there. A few of the successes, the project's not done, but we found that the Oklo model was a success at UAF, as in contrast to the current coal plant. We found that the Vinci model was a success at the Red Dog mine, as opposed to the 5 diesel generators they have in operation there right now. I can't say for certain, but I also expect the Vinci to be a success at Fort Wainwright, but that model is still ongoing. Disappointments is kind of a strong word. I really didn't have any disappointments from this past summer, but again, sometimes waiting for the nuclear folks to get back to us took some time, and I think every intern probably deals with lag time. Satisfactions, I think everybody likes to see, positive results. Nuclear power is something that I find incredibly interesting, especially in Alaska, where other renewables may not be as effective. So to see positive results for a nuclear micro reactors is something cool to see. I'm an electrical engineering student, so some of the energy jargon went right over my head. And nonetheless, Dr. Dankenberg and Dr. Ray were there to help me every step of the way, despite how idiotic I felt some of the questions were. So I cannot thank them enough. If I were to leave with one thing, I believe the fuel cost is probably going to be the biggest deterrent for nuclear, at least at the current moment. For, let's say, Vinci. The Vinci model has a refueling period every 8 years. That the fuel by itself costs $3 million to refuel it. It costs an additional $20 million to transport the nuclear fuel. So, that adds up pretty quickly. That's just, licensing and things of that nature. So that was the biggest reason, or at least we found thus far, why nuclear wouldn't work at certain sites, just because of transporting that fuel. I think that's it. Questions? Cool. That is a great question, which we never discussed. I don't know. I really don't. Pardon me. Oh, the question was, how would you transfer the nuclear fuel to remote Alaskan locations that didn't have road access or barge access? That's not something Dr. Dankenberger and I ever discussed. It's kind of out of the scope of what we were looking at. A valid question, though. But I don't know how we would do that and how that would be done. Dane?
Yeah, this is Dave. I think there would need to be barge access, and I think most communities do have barge access. I don't know, someone could jump in.
Mhm. Yeah, so one of the first things Dr. Dankenberg told me when I took over in the summer is he said, I keep forgetting to do that. Yeah, the question was, did we look at the, combined heating power as opposed to just meeting electrical efficiencies with the nuclear reactors? And Dr. Dankenberger told me the first, or I think it was the first week I got here, that if the nuclear reactors were not combined heating and power, they would never work, or something along those lines. So we did look at that. So the loads we would put into Zendi were both space heating loads along with the electrical loads. And the way we model it in Zendi, the nuclear reactors are the ones we had were combined heating and power. So they are providing both the heat and the electrical to meet the load. Yes, so Zendi produces both in its values. It produces both fuel costs along with electrical efficiency costs. So for the grid connected sites, one of the things we looked at is whether or not it would be cheaper to import electricity as one of the alternatives. So we looked at purchasing from GVEA alongside with running the coal plant along with the nuclear reactor, and often cases it did purchase a bit from GVEA. So that was one of the things we did look at, if that answers the question. So Dr. Ray had mentioned a few things about that. He says, while they are advertising, repeat. Yeah. So the question. Oh, yeah, Richard, to answer Rich's questions, looking at the unit costs. Dr. Ray was one of the guys that I spoke with quite frequently saying, while these are the values that are being advertised, they may not be exactly correct. It wouldn't surprise him if the cost for the Oklo reactors was higher than the $10 million advertised price. But we wanted to know, how high could that cost go before they were no longer effective? Yeah, so if I understand the question, why ever have the combination? And that was usually only when we had transition periods. So for Oklo, I think I ranged the price from 10 million up to 30 million, just to see at what point, is it all coal, or what point is it all nuclear, where the combination factor is. So I think between 17 million and 22 million, if I remember correctly, it starts using a combination of the two. I'm not sure any company or any site would ever want to construct multiple things. I mean, multiple different technologies. That's just how it was modeled with Zendi as the prices fluctuated.
Yeah, it can make sense if you want to run the nuclear, all the time, ideally, if it's like more capital intensive than coal, and then have a little bit of coal that's not run 100% of the time.
So I believe the interest rate we were using was 5%, although one of the other things that Zendi does not do, it doesn't have inflation rates or anything like that. So that's something I probably should have included that in the presentation, a future improvement. But I do believe the interest rate we were running was 15%. Although I may be wrong on that, I might have to get back to you. Yeah, so the question was, would UAF ever transition to nuclear after having just built a $245 million coal plant? We took the greenfield approach. We don't think that they would ever switch to nuclear just to save annual cost after just investing 245 million. So we said, we took the approach, if at the time the new coal plant was being constructed, would it have been a better option to go with nuclear? Anything else, Cole? Can you, I'm not sure I understand the question. Yeah, I'm just the modeler.